All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. We are going to tackle something a little bit different tonight. Something that's kind of come up on stream a couple of times that I've mentioned I kind of want to tackle, and I think I want to go ahead and knock it out tonight. So we're going to talk about that tonight. But before we do, I do want to just take a quick second and thank the supporters of the channel. Starting with our elite partner, Javier Lazaron. That is the top tier of subscription over on Patreon/YouTube memberships. I'd also like to thank our partners, Gerbolis Inc. and Matt Oscard. That's the next tier of subscription there. And I'd also like to thank all of the other folks listed under the supporters section. They're a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you guys very much for that. It is greatly appreciated, and I'm going to need those funds as we develop this game, for sure. So thank you very much for that. And of course, speaking of support, I wouldn't be able to do this without you guys, the viewers, whether you're joining us on the YouTube side or the Twitch side. We do simulcast both. Without you guys, this project and this channel would not exist, so thank you guys for being here. Much, much appreciated. Soulfoam, I see you're the first one here. How's it going? Spiro, no, you were not first this time. Nope. Let's see. Yeah, OnlyFans, right? Yeah. Nobody would pay me for that. In fact, people would probably pay me to not have one. So maybe there's a thing. Alt Nation, how's it going? Good to see you over there on the YouTube side. It got me interested now. Yeah. All right, so special topic. I want to talk about ECS, or the lack of one, right? And the direction of our scenes and what we have been doing thus far and the way I want to take it. Right. So, what we have now is not ECS, but it's something that might be considered closely related, right? So, we have a sort of structure where we have a scene, right? And then inside that scene, we have nodes, right? And these nodes can have transforms, right? So they can have X, Y, Z, position, rotation, scale. And then within those nodes, they can have what we refer to as attachments, right? And these attachments are they all have their own individual type, right? So you can have something that either gets rendered or plays a sound or any number of things, right? And so what we get out of that is we get a scene file that looks a little bit like this. Let me close this one over here for a second. So what we get out of that is we get something that looks like this, right? Where we have this sort of global array of nodes. This is a scene file, right? And each node can have some properties of its own. It can have an X form or not. And then it can have a series of attachments, right? So the idea was that not every node needs a X form because you have some attachments that don't need X forms. Like a skybox doesn't need an X form and a directional light doesn't need an X form, right? And this kind of makes sense, right? But this is actually making things way more complicated than they need to be. Maybe a little bit more flexible, right? But there are some issues with this when it comes to complexity of code in terms of both parsing this file, but also setting things up in the scene, right? Because you can't just have these attachments just sort of freestanding, right? And so, I kind of went with this system just as an experiment to see how kind of it would turn out. And it works okay. But I've been saying for a while now I want to rethink the design of this, and I want to sort of refactor it and come up with something that's a little bit more data oriented, so cache line friendly, right? But B, also a little bit more simple, right? I want to get rid of some of this overhead logic that we have and simplify things a little bit and cut things down a little bit. And so, we kind of have some hacky stuff in here around things like spawn points, for example. We reference those by name, which I suppose is a valid thing we could do in game code, right? but maybe it's not necessarily all the way that we want to always do it, right? And then, for something like our player, we have like a player mesh here. Eventually, there might be, well, there probably will be more than one mesh. And those things will have to be, parented to one another. For example, the player mesh holding a sword, right? You'll have to have another node and then an attachment on that, right? And so I think this whole system is just a little bit more cumbersome than what we need to make a game. So, rethinking, right? Let's see. I have so many opinions on this. I'm going to force myself to keep working on my game and not write a 5-page essay. I have opinions on it too, for sure. Orshi, good to see you as well. How's it going? All right. So, this is not really the direction I wanted to go, right? I kind of went this way because my brain was telling me that, like, just because, I've always kind of done it this way in the past, that maybe this is the way to go. And I really got thinking about it, and I'm like, you know what? This sucks. We're not going to go this way. Let's see if we can simplify this a little bit. And so I'll go ahead and split the view over here, and actually, yeah, let's keep the let's keep this one over here, and over here on the left, we'll go ahead and go open a new zone file that I've made. All right, now at first glance, this might look very similar to what we had before, but it's not, right? So what I'm going to do, and what I'm thinking, is completely dispensing with the idea of attachments. Because at the end of the day, what was a node doing other than just providing a container and potentially a transform and a name, right? And then maybe you could add other children to it. What's the purpose of separating that versus attachments, right? So instead of having nodes and attachments, maybe everything's just a node, right? So we have one node here that is our environment node, right? So I tried to kind of keep the structure relatively similar to what we have here, but in a different format. So what we're going to do is we're going to specify a type for each type of node, right? And we actually have this this string here, which is going to map to an internal k name, and that's going to tell us how to set the node up, right? And then those nodes just have children, right? So a group node, its only purpose is to basically serve as a parent to other nodes. It doesn't really have any properties of its own. It just is what it is. And then things like specialty nodes, as I'll call them, actually have a different type. So we have a node type skybox here, which has an image asset name for the skybox and a package name. We could probably just do that. We could probably just simplify it to that, right? Asset name, package name. In fact, this should probably be resource name for, so it's consistent. And then also these children all have names, right? So we could just name them something, reference them by name, and so forth. So our directional light here, we're just calling it the sun, right? And that's essentially just the light, a directional light type of node. We have another group node here with a new type of node, which is a node type spawn point, right? And so at the moment, a spawn point just is not really any different than a group node, but I suspect that we may have some difference at that point going forward, right? So we've got a couple spawn points in here. We have a player node, which we haven't talked about how we're going to handle that yet. But essentially, it is a group node itself, and then it contains a player model and a hit sphere, and eventually it can contain other children and stuff like that, right? And so it has a static mesh and a hit sphere type of node. So these are, again, new types of nodes. Here we have a volume type node, and then we have various properties of that type of node. And then we have another static mesh, a water plane, and then we have a test fire here, which is, I'm actually making this a group node. And then we have a fire audio emitter in it, which is just an audio emitter. And so we might attach a light to this, like a point light, for example. And and we might also attach a particle emitter to it, right? Or a couple of particle emitters. And then, you'd be able to have this whole thing as a unit. So this, I think, is much more straightforward in terms of not only setting up a scene, but also the code behind it is going to make a lot more sense, I think. Let's see. You know what? I completely forgot about the 7TV thing. I forgot to register it. Yeah, you're right. That is on my to-do list. I just forgot to do it. I got busy with stuff offline. Thank you for reminding me, though. Little Carlito, how's it going, by the way? All right. So this is the direction that we're going to go. Westfall Banger, exactly, yes. I love this track. It's one of my favorites. So I think this is going to be a lot easier to deal with. The other thing that I got thinking was, we've done a lot of discussion around user types of attachments, right? We kind of talked about that, and we're like, well, what would that look like? And we kind of briefly talked about some various ideas of that, right? But when I got thinking about it, when we get down to brass tacks, why would we ever actually need that, right? All that we would ever need to have in here in terms of node types are the basic types that the engine supports, right? To display a mesh, or to display a skybox, or a light, or something like that. And so when you think about it, it's like the only thing that we really ever customize would be something like this player here. And all a player really is just a combination of nodes. So we could potentially add something that just handles this via prefabs, right? And we just spawn a prefab at a spawn point. Or maybe we eventually add a player type, right? That has a few sort of nodes that it comes with by default, something along those lines. I haven't really decided yet, but I don't think we need a custom type for this. I don't think we need user types of nodes. I think all we're really looking for with this is a prefab. And I think if we build it in a prefab, I think we would be good. Yeah, been busy. Like I said earlier, the OnlyFans account doesn't sell itself. Yeah, I was saying that people would probably pay me not to have an OnlyFans account, actually, if anything. Magetz, good to see you. Hope you're doing well. All right. Anyway, so this is kind of what I want to think about tackling tonight. And I've actually written a little bit of code, most of it just kind of figuring out structures and stuff. So I actually want to, let's take the code over here, and we actually have a kscene .c file, a header file rather, that I've kind of started laying out a little bit, right? And so this is one of the things that I kind of wanted to talk about tonight. The other thing that I wanted to talk about, which I know for a fact we're not going to get to tonight, but I do want to actually think about as well, is in our app config, we have this render graph, which is a big nebulous configurable thing that allows us to set up a single frame. I really like this idea when I put it in. But again, this is another one of those things where I think it was cool to have, but I think it's way overkill for what we're doing, and it's way overkill for anything we're going to do. And so this is going to be another thing I'm probably going to wind up factoring out. Reason being, I want to replace that with something known as a graphics pipeline, right? Not to be confused with Vulkan graphics pipelines. That'll have a generic flow that looks a lot like this. That instead will essentially allow you to configure it, but not have to set it up in this way, not have to set up all the passes and some of that stuff. Because when we get down to it, like there's a lot of this stuff that really just doesn't need to be configurable. And so, yeah, this is the other thing that we're going to think about factoring out is this. And we're basically going to come up with a default sort of graphics pipeline that handles a lot of that stuff for us. And then, of course, things, add-ons like standard UI and editor stuff will be tacked onto the end of that. So I haven't fully thought that out yet, but that's kind of another thing we want to talk about. Let me see. Holy moly, the Chads are plentiful here tonight. Yes, seems that way. Let's see. I wouldn't subscribe, but I'd give some subs. Let's see. Yes, Soulfoam, please bug me to get the 7TV thing set up. I need to do that for sure. Smudge, how's it going? Let's see. Rugs, good to see you as well. Hope you're doing okay. All right. So with all that discussion, I'm going to actually take this back to the scene file. And what we're actually going to do, since this is version 0.9, right, we actually haven't like had a full-on release of like a 1.0 or anything. I'm actually going to reset the format of the zone to 1 because we're not going to support the old format anymore. We don't support the format before that either. So I think it only makes sense that we just, kind of roll this back and rethink how we're going to handle this. All right. One more thing I should probably talk about also before we actually jump into discussions of the new structures and whatnot is you may have noticed this K-handle 16 in here. And so if I go to that, we still have the K-handle here, right? Which is essentially our what we use to index into a lot of our resource arrays. A lot of our systems use these. They've been pretty handy, no pun intended. But there's a slight issue with it, right? And so that issue is an issue of size. So the handle index is a U32, right? And then the identifier itself has a U64 inside of it, right? And so the issue with this is that, this is kind of large for what it does. And we have lots of these. And so I got thinking about this and I'm like, you know what? We really don't need a globally unique identifier for our handles, right? It's really just like a generation thing that we can kind of manage separately. And none of our systems are large enough where we'll ever have any more than 64,000 or 65,534 elements. And so this could really be a U16, and then this could be a U16, and it'll be a much smaller structure, right? And so obviously this comes with a limitation of you can only have 65,534 values because 65,535 is invalid ID U16, right? And so that's what we use to identify an invalid handle. But the K-handle 16 is basically a smaller version of the handle that works almost exactly the same way with a couple of differences, one of those being how we index. And so we could save a lot of memory across the entire system by using these. Not only here, but also anywhere that we are indexing to, the counts and whatnot can all be U32s, U16s instead of U32s. Let's see. So that is basically what the purpose behind this is. And then we also have all of the functions here that are very similar to the regular K-handle version, with the difference being that we reference generation versus unique ID. So we can create it with a U16 generation, and then we also have a update function, right? And so what this update function does is it simply increments that generation. So anytime we go to reuse a handle or we go to, say this handle is, or anything any handle to this particular resource is now invalid, we could just call khandle16 update, right? And all that does is just increment the generation, and then if it winds up being invalid ID, it just rolls it around. And this is a much simpler solution than what we had before, and we don't have to manage as much handle stuff in our user code as we did before. We can just kind of call a couple of functions and be done with it. So this is going to be something that I'm going to switch everything in the system, in the engine to at some point. But I wanted to go ahead and get this in now because I don't want to write yet another system that I have to switch. So the idea here is that I'm essentially going to switch everything from being a khandle to a khandle16, and then I'm going to rename khandle16 to just khandle and nuke the old khandle. And that's the way we're going to work. Let me see. There's a couple of some chats here I missed. Been crammed with studies. Rugs, I can understand that. I hope those studies are going well, though. Hope it's all good. Diamond, good to see you as well. Jan, thank you for the follow. Appreciate that. Let's see. I'm sure I'm not catching all the chat, but let's see. For this one, I actually have a cool trick I use. All my handles are 32 bits, but it's up to the system to decide how to allocate to index and generation. Some systems have 24-bit generation and 8-bit generation. Some has 16 to 16. That is kind of interesting. I don't know that I would need that. I don't think I have anything that like needs to update generation quite that much. And if I do, it just rolls around anyway, so I can check a mismatch, right? So I think that should... I don't think I need that, but that is something I can keep in the back of my mind. Just cast the int to a pack struct backed by an int internally. Yeah, that makes sense. Can you run your program and show some nice graphics on the screen? Let me pull up the other project. I can pull up the testbed project, I think. I don't think I've broken it at the moment. If I have, I won't be able to do it, but give me 1 second to pull that up, and I can just kind of see if the testbed application will even run. Yeah. All right. So this is sort of our testbed application that we use to test new features as we add them. And so one thing that's missing right now is terrains. I have to add those back in. But we have a little bit of work to do that, and terrains aren't an immediate need. So that's on the backlog, but I do need to get around to that. So this is what the engine looks like kind of now. We've got some static meshes in there. Here's the Sponza test that everybody uses. We've got the water plane in there. And then also we have a couple of different views. Let me go back in here. So we've got a couple of different views, debug views. So we have like lighting only, where we can just see how the lighting affects the scene without taking texture color into account. We have some normals there, so we can actually see how that looks. We have, for the cascading shadow maps that we have, we've got a visualizer on that. I'll have to go outside the Sponza to actually show you the full gambit of those, but basically we've got 4 sections that are color-coded, so you can kind of see where those cut off for debugging purposes, right? And then, of course, we have the quintessential wireframe view as well. So we've got all that, and then, of course, the normal view. And you can select objects in the scene and move them around, and you can rotate them and, of course, scale them however you want, including negative scale, right? So we can actually scale it negatively if we want to, and it handles that. And so, yeah, that's more or less what we have at the moment. There are some other gameplay systems and things like that that we're implementing now. We have a light UI system that's got, clickable buttons and UTF-8 based text and a debug drop-down menu and things like that, where I can type commands like exit. And yeah, that's basically what we have for right now. Let's see. It is handy to have some systems that need more than 65K elements, like transforms. So, transforms are something I've also been thinking about. So right now, we actually have this node hierarchy graph that we use as a view in the scene. And we also have a sort of external XForm system that just holds transforms system-wide, engine-wide. And the more I've thought about that, the more we also don't really probably need those separations either. So I am actually going to move transforms to be, they're actually going to wind up being part of the scene. And the reason they're going to be part of the scene is because scenes I'm also going to use to render the UI at some point. And so when we get ready to do that, we'll just be able to use the same transforms as we would otherwise. And we're going to use transforms through the scene itself, I think. I don't think we need a dedicated system for it with IDs and all that stuff. The more I think about it, the more I think we don't actually need that. Was it hard to do the water? Never got that far into 3D graphics, so it seems like magic to me. So water is actually not that difficult. You have to draw the scene a total of 3 times in this case, because I'm doing planar reflection, right? So you have something called a clipping plane that defines whether you can where the rendering cuts off. You know what? The best way to describe this is actually probably ye old render doc. Let's see. Let's see if I can get this to work. All right, so let's see. Let's go. I guess we could use the inside of this sponza, right? So you can kind of see that there's reflections and refractions going on, right? So I'm going to take a capture here. All right. And what we're looking at here is this is the final scene, right? So if we actually take a look at, actually looks like I have my debug labels off, so it's going to take me a second to find this, but it looks like probably here. Nope, that's the shadow pass. Probably going to be, which one is this? Okay. So there's one of them. And then, okay. So what we essentially have is, actually, I think I can just use this. It's not going to show me all the way through, I guess. All right. So what we essentially have is we render the scene 3 times, like I said. So we render the scene once from above, which is probably going to actually be this one. So once from above the water line. Nope, that's still below. Did I do reflection or refraction first? Maybe I did them in the opposite way. Which one is... I think this one's everything. Yeah, okay. So is this one? No, this is everything. Let me turn my validation back on so I can actually find the freaking render pass. Give me a second. Let's see. Let's take a new capture. Okay. The frame rate's not as good on this because I have the... I'm just going to take the screenshot from here. Actually, that's probably not a great screenshot. I probably should still do inside the sponza. Because there's not as much stuff below the water out there. Okay. So let's open this one up. There we go. All right. So we have our forward pass, right? So in our forward pass, we actually have 3 passes on the scene. So we have a forward refraction pass, which is basically where the camera is above the water plane, right? And it's in its normal position in this case. And we're basically rendering only things that fall below the water plane, right? So anything that's above it gets clipped off. And so when we click into that, we get... Scroll this down to about here. Texture viewer, here we go. Right, so as we're drawing all this stuff, this is all stuff that's only below the water surface, right? So this is, you can kind of see in here where the clipping line is, right? So there's that. And then the next thing that we do is we do the reflection pass. So the reflection pass is basically the entire scene, but taken from underneath the water plane, where you basically take the camera and invert it across the surface of the water plane so that you're looking up. And what that does is renders everything above the water plane so that you get something to use in your reflection, right? This becomes your reflection. And so those 2 passes are rendered to a separate texture. And then you do one final pass on the scene, which is here, which includes everything, right? But also includes, where is it? The water plane itself, right? So the first 2 passes, you don't actually draw the water plane. The third pass you do, right? So that's what it looks like before the water plane is drawn. That's what it looks like after. And essentially, when you draw the water plane, you take the reflection and refraction textures, you mix them together. You use another texture called a DU/DV texture to offset the texture coordinates of that, and that's what adds the sort of waviness and bumpiness effect that you see there. And that's essentially how you get that. And then the surface or the corners here, or the edges, are blended with alpha. And we essentially get that from the depth buffer that we render in the first 2 passes. And that's essentially how we achieve that effect. It's an oversimplified version of it, right? But it's not something I want to do a deep dive in now. Let's see. Okay, catching up on chat real quick. Editor is awesome. I'm trying to make something similar to 3GS right now. Yeah, I mean, our editor is basically going to be very ad hoc as we need things. That's essentially how we're gonna do it. Interesting. I don't have a concept of a scene in my engine, so I could probably get away without a concept of a scene as well. But But for me, it makes things a little bit easier to fragment and separate and split up into zones if I have scenes. Otherwise, I'd have to set up like an asset streaming thing based off of where you are in the world, which is more complicated than I want to do for this game. Doing some research on how to do scene graph traversal on the GPU. I mean, that we might get to that eventually. Thoughts on that? Let me see. What did I miss? I think I'm going to switch to NeoVim and use a NoVim plugin that someone sent me. Wait, what? A NoVim plugin? What is a NoVim plugin? I have questions. Right now I don't support hierarchies on my scene. Yeah, that was something I supported from the very beginning. Let's see. Interesting. And would it be difficult to implement ripples and interaction with solids? Right now your water just goes through the solids. I mean, ripples would probably just be adding another normal to set of normals to the normals of the water, right? So that probably wouldn't be too difficult. Unless you wanted like dynamic waves and stuff, then you're talking about something completely different. And if you're talking about having like dynamic waves that like bounce off the surfaces around here, yeah, there's a lot more involved in that, for sure. We're not going to be doing that in this game, that's for sure. It gives Windows shortcuts for NeoVim. Why would you want to do that? That's terrible. Ripples are also textures. Yep. There is a Sebastian Legge video for that. Yes, there is. There's a Sebastian Legge video for like a lot of other stuff too. He's got a lot of good stuff. All right. So, what I'm thinking is that did render.crash? Sweet. Okay, well, I'm just going to move that out of the way for now. So what I'm thinking with all of this is that I don't actually want to have any more than 65,000 objects loaded at once, at least in a single scene. So that limitation is per scene. It wouldn't be for everything. So if we decided we wanted to render more than one scene at a time, we could do that. And we could probably semi-easily add that at some point. But anyways, getting back to what we're going to be changing to. So we're going to use khandle 16s for everything, specifically nodes at this point. And I'm just type defing that as kscene node, just to make it a little bit more clear as to like what the handle's used for. So wherever we define a node in the system, that's actually going to be referenced using a kscene node, which is really just a handle. And so we have, as we have before, states for the scene. So there's an uninitialized, initialized, loading, loaded, unloading, unloaded. And I'm not 100% sure I'm going to stick with this, and we'll get to why. But for right now, I am going to leave it there. We have some scene flag bits that was carried over from the old scene system, which still exists, by the way. I'm developing this in tandem, and then I'll just cut over to the new stuff. So here's a type def for the combined bit flags, and then we have node types. So we're essentially only going to ever have known node types in this engine going forward. So there's not going to be concept of attachments. There's not going to be a concept of any of this stuff. It's all going to be nodes, and there's going to be known types of nodes. And if you want something special, you can group them together and or create a prefab that essentially groups them together but allows you to load them all in as one. And that's how we're going to get user customization, right? Because all user customization is, at the end of the day, is some sort of combination of these types of nodes that have a specific way of interacting. And so that's the way we're going to handle that. And yeah, let me see. All right. Singy, good to see you over there on the YouTube side. How's it going? All right, so we'll talk about node config because I actually haven't got that laid out completely how I want it yet. So we'll talk about that in a bit. But we have a couple of different things here. So one thing that I wanted, a couple requirements that I had for the scene, is I want to be able to quickly iterate nodes. I want to be able to represent hierarchy of nodes and be able to iterate that quickly or traverse that hierarchy quickly. And then I also want to be able to have nodes be tagged or have tags assigned to them and be able to query that quickly. But the most important thing is to be able to iterate nodes, right? And so we're going with a little bit more of a data-oriented approach on the way that all this stuff is set up. Starting with transforms, right? So in here, we actually have transform data that's represented here. So there is no transform or xform struct. These are essentially arrays of the individual components of what you would consider a transform. And then the index of these would be a transform ID that is used to index these, right? So these 4 arrays right here, positions, rotations, scales, and world matrices, are what is going to be used predominantly by the transforms that we actually get and use. So the way that this will be set up is, we'll obviously probably use like something like D arrays that expand as we need to expand them, and then we'll just use free IDs and whatnot to select these. I haven't figured out exactly how I want to represent free transform slots versus not free transform slots yet. So that's something I'm going to have to think about. But we do have a tracker for dirty transforms by ID. And so the way that we're basically going to handle this is once per update loop, we are going to come through and say, okay, all of the transforms that have been marked dirty in this list of IDs, let's take those and recalculate their world matrices, right? And then we're going to cache those world matrices. I haven't decided whether I want to cache the local matrices or not. The other thing is whenever we update a transform anywhere, any transform that is a child of that transform via the hierarchy is also going to be marked as dirty. That way we don't have to traverse this twice. We could basically just say, okay, on the update loop, here's a list of all of the dirty transform IDs. Recalculate these. I would test that. For me, caching is barely better. Yeah. And I mean, the thing is with doing it this way, refactoring this would be a lot easier. If I just need to add a property, all I need to do is just add another array, right? So, I mean, we can profile it for sure, but this is kind of the way I'm going to set up most things to make them easily queryable. So the way that we're going to handle hierarchy data for nodes is the hierarchy data is the nodes themselves, right? So they store everything that we're going to need in terms of node information. We don't actually have types in here, so that's going to have to be added somehow. I might put it here. I might put it here. I haven't decided. But we have generations, which are going to match up with the handles. We have a parent ID for each one. So if a node does not have a parent ID, it'll just use invalid ID U16 instead of something else. Same goes with first child ID and next sibling ID. So the way that we would iterate this this hierarchy is if we needed to traverse the nodes themselves down through the hierarchy, we would say, hey, is the first child ID invalid ID or not? If it's invalid ID, that means it has no children. If it's not invalid ID, then that means that that is the first child, right? And then to iterate siblings of this, we also keep track of a sibling ID. And you can think of this almost winds up being a linked list, right? But not stored in the same way that a linked list is stored. So each node is either going to have a next sibling ID where it'll know the sibling that's next to it, or if it doesn't have a next sibling, then that means you've reached the end of the list, or it doesn't have a sibling at all. And then, of course, the ID of the transform that's associated with this node, which goes back to this guy, right? And then, of course, an allocated count for that. Not to shoehorn Zig, but multi-array lists and Zig are magic for stuff like this. I've heard about that. Yeah. I'm not going to convert to Zig, though, just for that. Zig has other stuff that I don't really like. Syntax is one of it. I don't really like Zig's syntax. But yeah, I get what you mean. I definitely don't want to switch languages 4 years in, right? Okay. So node type data, this is kind of where I left off in terms of how we're going to represent the individual known types of node data. So we're going to come back to that actually, because I want to talk about these other couple things that we have here, and then we'll come back to this. So tag data is basically a view of tags, right? And so this is also set up in a data-oriented kind of way where we can just iterate on the tags very quickly. Each of the tags, a tag is actually just a k-name, right? And so we can iterate on those or look it up in a binary tree or something like that if we wanted to. We could very easily hook that up. And then we have a tracker for all of the items using these tags by ID. So for each tag, we'll have a list of nodes that are actually using that. And so this basically becomes another view where we can query where we want to say, okay, give me all of the nodes that have this tag. And then we'll have a list of those. Maybe it gives you inspiration for your development is all. Yeah, no, that's fair enough. Writing something like that in C might be interesting. I don't quite know how I would attack that without... I don't know if I could attack that without like some really weird macro stuff. I think Zig is a bit too verbose. People say that about C too because it doesn't have namespaces. So it's preference, right? Okay, and then finally we have the k-scene, which is a structure for now. So it's got our basic stuff up here at the top where it keeps our basic properties. We keep a pointer to the config, the resource config, which we're actually going to have to define a new type for that, or maybe just replace this one. I haven't decided. And so we have our transforms, our nodes, our node data types, and our node tags, and then a binary tree for node lookups going from name to node, right? So that is kind of the new structure that I am thinking of for this. And from there, essentially, we're going to figure out how we want to store the type data. So obviously, when it comes to dealing with types, right, we want to have all of the different types of nodes have their data very tightly packed together, again, and sort of a way like this that's very quickly iterable, because typically we're only going to use a lot of those fields one at a time for a lot of quicker operations. And it's going to depend on the actual on the node type itself. For example, like for skyboxes, that doesn't really matter as much. For this, it doesn't really matter as much. But there are other types where it might matter, like this kind of stuff, right? where we may only want to reference one or two of these fields at once. So we may need to play around with those types a little bit. Just happy there's modern languages that don't suck, as long as we all agree that Rust sucks. That's funny. C verbose versus Zig verbose is worlds apart. Fair enough. Yeah, that's fair enough. Verbose for different reasons, I guess, right? Okay, so what I was thinking here. What was I thinking here, actually? So array of base node IDs, one array per, and indexed by node type. So I don't know. We have these known types up here, right? Which I was thinking of using this to index into that array. And then we say, what are the base IDs for group nodes? Give me the list of base IDs for skybox nodes, for directional light, et cetera, et cetera, et cetera. I don't know if that I want to split it out quite that much, though. The advantage to this would be, this would make it very fast to say, give me all the nodes of a specific type. But I could also argue we don't need this structure to do that. We could also do something like, if I could type, so we could do kscene node. Let's see, node. What do I want to call this? I guess we could start with group data. Node type group data. That seems a little bit verbose, but we'll roll with it for now. Right, and then maybe we also have, let's use something that's a little bit more concrete, like, I guess our skybox. Whoops, kscene node type. Really can't type tonight, apparently. Skybox data. Okay. And if we take a look at the original scene.c, we have some stuff in here that represents kind of our internal lists of renderable things, right? And these are all kind of handled a little bit differently, and we actually use the underlying type of the thing itself, which is not always necessarily what we need or what we're going to want. So let's use Skybox as an example. Skyboxes just uses a direct skybox, right? Which, if we look at what a skybox has, it has, a cube map name, a resource texture, geometry, right? And then a group ID and a draw ID. And there's not a whole heck of a lot to a skybox, right? So we've got this kind of separated here. And like, this kind of makes me think, like, do we even need this to be set up this way, or could we just do this in the scene? And this is kind of where I'm thinking, like, should we always just kind of enforce the use of a scene and say, never mind about trying to manually render this stuff, right? Because the problem is that I'm quickly realizing as I do this is, if we try to support both, if we try to support saying, like, hey, we have an application where we want to use an editor, and we want to use scenes and all this other stuff, and we want to use render graphs and all this other stuff, and you can set all that stuff up through configuration, but then maybe we also have somebody else that wants to build an application and do all of that stuff through code. supporting those two paths are very different things. And they each have their own complexities, right? And I feel like there's not a lot of value in supporting both. I feel like that's kind of a vector for bugs, because if they call the instantiation of certain resources incorrectly, that could lead to weird behaviors and strange things happening. So I don't know. I think that I'm thinking that maybe we just say we always need to use scenes and then use scenes to actually load stuff. Let's see. You guys still talking about Zig over here? Use Zig's comp time so much I can't go to another language. Maybe Jai when it comes out. Yeah. So, Diamond, you actually bring up a good point about that. Like, comp time was one of the things that I was really interested in looking at Zig. Right. It's one of the features that I kind of miss from C++, being able to do things at compile time. Right. Namely, compile time strings. And I'm still on. Every once in a while, I'm still considering switching to the C++ compiler just to get that feature, right? But yeah, I feel like Zig has not been around enough. It's not mature enough that I would want to put all my eggs in that basket, as Maget says. I don't know. I don't know where it's going to be in 5 years, you know? C and C++ I know aren't going anywhere. So there's that. That's always been kind of my hesitation. Same thing with Odin, right? Odin looks pretty cool. It's got a lot of stuff going on, but wait, you can't do preprocessor stuff in C. So you can, right? But like doing something like hashing a string in compile time is actually pretty tricky to do in C. Whereas in C++, you can actually just do that with a constant expression, and it's just C code, right? There are ways to pull it off with macro magic, but boy, is it ugly. And there are other drawbacks to it as well. But yeah, it's not something that's easily done in C. And it's one of the features that I miss from C++. If I had, there's two. There's that and operator overloads. And I only miss operator overloads for things like math library stuff. And that's basically it. So like if I were to switch to C++, those would be the only two things I'd use. Praveen, how's it going? Good to see you. Question, if I were to make a different game app using the engine, which commit can I fork from? How would one go about getting the upstream engine code changes? So that still has not been completely worked out yet. And that's one of the reasons that we're, doing all of this kind of work now, is to kind of sort some of this stuff out before we dive too deep into it. So right now, what we're doing, and I think this is probably what I'm going to go with. The way that this works right now, let me collapse some of these folders here. So the way that this works for this particular project that I'm working on right now is we have this folder structure here, right? Which the main points of this are: we have the application, we have the code library for the game, right? So we have those two, and then we have a Git submodule where Kohi is in that. And this can actually be, this submodule can actually be tied to a branch or even a specific commit as a submodule. Git submodules allows you to do that. So what you can do here is very easily say, I want to use 0.8, right? And just switch to the 0.8 branch if you wanted to. And then anytime you go to do a git pull on this, the only time you would ever get an update is if it was actually went to the 0.8 branch. Which is, good for stability and not accidentally upgrading things and stuff like that. Obviously, if you wanted to step that up, you could very easily just do that with a couple commands in Git and pull and do that. And so this is kind of the way it seems to be working pretty well so far to do this, because the other thing is I cut release branches like 0.7, 0.8, 0.9. But then I can also go back and I leave those branches in place so that I can actually go back and do retro fixes into those if I need to. So if we have, if we're on version 1.2 and I find a bug that also affects version 1.1, for example, then I can go back and do a bug fix on that and have version 1.1.1. And then, you know, anybody using 1.1 could just update their submodule to use 1.1.1. And I probably would just make a small little utility that just kind of wraps that functionality. But that's kind of what I'm thinking as far as that goes. MDS Ubuntu, 3-stream streak. That's awesome. I just saw that just now. Appreciate that. All right. Just write a preprocessor yourself and make it preprocess your C files in your pre-built step. So I thought about that too, Magettes, right? But the problem with that is it makes your code woefully unreadable, right? And there's all kinds of other issues that come with that. So that wasn't really something I wanted to do either. Because if I did it, I would want to use, you know, I'd want to have something in here where I could just do kname, you know, some string. And then during compile time, this, you know, would just be, we just do, I don't know, name equals, right? This bit right here would just get replaced with, you know, some number, right? And that would be done at compile time. That's ultimately the goal, but yeah, it's a little bit more tricky to do with C and macros than anything else. Simply just, yeah. I actually did think about doing that though. And actually that wouldn't be that hard to put in a preprocessor to do that. It's just, I'm just a hobbyist, so I'm fine betting on Zig. But the magic moment for me was creating a parser that can read and write a structure definition to and from file live. And I can know at compile time the length of the loop. And in release mode, I can compile all the files into binary using the same code and create static string map at compile time to reference these binaries. Yeah, that's all pretty sweet stuff for sure. But yeah, I mean, this is an engine that I eventually am not only going to be releasing games on, but I expect to release in such a manner where other people can use its built games on as well. It's nowhere near that point now in terms of other people being able to use it, but that's the goal. So I have to keep that in mind too. And one thing I want to do is eliminate as many dependencies as possible, and Zig would be a dependency, right? Basically, by the time I'm done with this, I want to have it basically be, you need a C compiler and the Vulkan SDK and OpenAL to build it, right? And maybe some X11 stuff if you're on Linux. Like, I'm eventually going to get rid of make too, because this K build that I have here is what that is. We're just not there yet. Okay. So if we talk about skyboxes, actually, let me go back to skybox. Skyboxes essentially had they have their own sort of state here, right? Which is, again, we could probably make this a little bit more generic, right? And then we basically just have this stuff, right? So if we went into our scene, right? Let's get rid of state for now. We could do right? Turn these all into arrays. And then these would also be indexed by like a skybox ID, right? And so you'd have a skybox ID that would be sort of the ID within that type, right? So you'd also have U16, what did we say, allocated count. And I would actually argue you probably don't need more than one skybox, but there actually is a scenario that I'm thinking of where you might need more than one. In fact, what was the name of that? Let's see. There was a zone in WoW that actually did something with skyboxes that I thought was kind of cool. Let me see if I can find it. I don't know if I'm going to be able to find a visual example of it, but basically, well, actually, this video might have it. It was a WoW Classic thing. Actually, this screenshot on this video will actually have it. So essentially, here. Let me see if they actually show walking into it or not, or if this is just the actual instance. I don't think it is. I think this is just the instance, unfortunately. What they had was basically you walked in like this desert zone and you went into a cave. And inside that cave, you had this sort of extra sort of skybox from within the cave where the cave sort of broke up and you could see this. And what this was an actual another skybox that you were looking at. And so when you're outside the cave, you get the normal skybox. And when you're inside the cave, you get this skybox. And so that was a situation I was thinking about where it might actually be useful to have more than one skybox. I don't know that we need a lot. We could probably limit this to like just a couple of skyboxes, but you know, in the interest of keeping things consistent, I think this is what we could do. Thank you for the follow, by the way. Zig is a C compiler, so it's not an extra dependency, but that's the last about Zig. Well, it is I mean, if you're using the Zig compiler, though, then Zig is a dependency of it, right? I mean, obviously that means the C compiler that you're using is a dependency, but yeah. How does skyboxes fit with dynamic skies? So, dynamic skies are a little bit different, but they don't necessarily have to be, I guess. So we could have a skybox is typically just 6. It's a cube map with 6 different images at different directions of a pre-rendered skybox. So it's literally just pasting those on the inside of a cube, right? And then you just render that according to whatever the direction vector of the camera is. And that's what you use to sample the texture. Dynamic skyboxes are the same thing. The only difference is you generate the texture that gets rendered instead of using a pre-rendered texture. So in concept, they're not that much different. It's just how you generate the texture is what differs. That's it. More than one ambient light too? You mean directional light? So that's one that like I don't think that I will do. I feel like directional lights, there ought to be one per scene. And like I even looked at this, like I used Unreal as an example. I actually went in there and created a scene with multiple directional lights. And they actually have something in there where you can actually set a priority of the light, which basically says which one do we want to use as the main light and then which one gets added after the fact. So that kind of blends them together, but it winds up looking really weird. And I don't think it's something that is completely necessary. I think one directional light is enough for a scene, for any scene that you'll do. And that's even if you have one. You don't necessarily even have to have one. So we're only ever going to support one, but for skyboxes, we might support more than one. I haven't really decided how many. I can't picture a scenario where we would need tons of them, but I could picture a scenario where we need a couple. What's a scenario where you would need more than one? So that's what I was just talking about, right? So, wait, Tatooine. Anything where you can cut out reflecting a skybox or doing lighting is probably good for your FPS. Yeah. Touche. Yep. Yeah, so, I'm thinking of... You know what, though? Technically... All right, here's another scenario. And again, I'm going to use WoW as an example of this because they actually did this pretty well. There are certain zones in WoW where when you walk into a certain part of the zone, the skybox changes, right? So like the quickest example I can think of is Outlands in old WoW, right? I think it was Hellfire Peninsula. Yeah. So, oops, let me move this over here. There we go. So Hellfire Peninsula had this kind of cool looking skybox that had all these sort of solar flares and planets and all this other kind of stuff, animated stuff throughout the sky, right? And then depending on where you go in the zone, sometimes that would actually change up. So there was, let me see it. Do they have an example of that? Because there was, it might go to something like this, for example, where it goes all green, right, and cloudy, and that looks completely different than this, right? And that would happen within the same zone, and so you probably wouldn't want to use one single skybox and turn things on and turn things off. You'd probably want to transition from one to the other and sort of render them both at once, but like change the opacity so that they mix together or something. In your case, wouldn't that be a separate scene? I want to say yes. And I'm really tempted to say yes, because that does simplify this, and I see where you're going with it. Mixing between skyboxes and the shader is easy. Yeah, that's true too. But we'd still need to have the different skyboxes loaded and have their states, right? You know what? Let's simplify this, right? Because now I'm actually thinking, well, actually, I'm still going to wrap it in a struct. But whoops, what was that? Casing node casing skybox data. I guess I could call this skyboxes, or I guess I could just call it skybox, right? I think for this game, one at a time is actually probably going to be enough. I think I don't really need to... I don't think I need to have multiples. Because also what I'm thinking now is like, the skybox is not all that important from this game, because the perspective of this game is mostly looking down. For cutscenes and stuff, you'll see it, but for the most part, it's not really going to matter all that much, I don't think, unless we change the perspective of the camera at some point. But even then, we will see about doing something a little bit more dynamic with the skybox in the future, I think, if we want to mix it. Loading multiple skyboxes is easy with bindless textures on the shader. I mean, I could even do that. I could even do that in the skybox shader now if I wanted to support multiple textures, right? But I'm actually thinking I want the skybox to probably be more than just textures eventually. But I'm not going to get into that now. All right, so we have that. Only one of these at a time. So the other thing what we would probably do is the directional lights, right? So we only have one directional light. And in that, we have directional light data, debug data, all this. Okay, so the concept of debug data is something I'm going to come back to too. But if we go into directional light data, I'm just going to grab this as well. And we're going to go in here and kind of do the same thing. So I'm going to go casing node type. I'm going to say dir light data, because otherwise that's way too long and obnoxious. Right, casing node direction light data, right? And here we're just going to paste this stuff, right? So we have color and direction, shadow distance, blah, blah, blah. And all this stuff winds up getting used directly in the shader, by the way. But I'm not going to worry about that in here anymore. We will translate this to what the shader needs elsewhere, right? We're just going to actually store this here for now. Thank you for the follow. I appreciate that. Let's see. Are you building a 3D engine? Crazy project. Do you have any release date? Yes, we are building a 3D engine. Yeah. Yeah, I can show it really quickly, but I don't want to get too caught up in that. Yeah. So, this is what we have so far. This is just sort of a test bed scene that I have set up to render just a couple of test objects. We can check out what the lighting looks like, minus the texture data, and then normal mode, shadow cascade mode, wireframe mode, and then there's the normal rendering mode. And so, we have that. We have the ability to edit objects in a very basic way, so we can move them around and things of that nature. The other thing is we also have audio, which you guys actually can't hear right now because I don't have it plugged through yet, but these spheres are audio emitters. So when you go into there, you can actually hear various things playing. But yeah, that's what we have now, and we just are working our way through rethinking our scenes at the moment. All right. Let's see. Can I start this series to learn game engine development? I only know programming languages. So we do talk about a lot of the concepts, although I do have to gloss over a lot of things because otherwise we wouldn't be anywhere near where we are if I didn't. So it does start off as kind of a tutorial, but then we change formats a few times as we move forward through the series to keep things moving, right? So like one thing that I always suggest, I suggest this book all the time, which is Game Engine Architecture by Jason Gregory. And it doesn't have like a lot of in-depth stuff, but it has a lot of good information about game engines, all the various systems and stuff like that. I recommend that book as well as following the series, right? But yeah, I mean, we talk about all of our design decisions along the way. Eventually I did have to stop doing everything on camera because it just wasn't moving quickly enough. But yeah, we you could certainly get into game engine development by watching this for sure. That was kind of the goal of it, right? Is to see how to build a game engine from scratch, but also all the processes, the thought processes behind it, everything that goes into it, and also to try things out and to show things that work and things that don't work and why. So we do a lot of exploration on this as well. It's not just straight like copy paste tutorial code the whole time, right? I hope that helps. It's quite advanced for a custom engine. Yeah, I mean, it's not too bad, right? I have a lot of work to do for sure. That's running on a very rickety scene system at the moment, so that's why I'm refactoring that now, just to make it a little bit nicer. And I think that's going to be the focus of this week. And then once I get everything moved over to the new scene system, we can move on to the next game mechanic. Okay. So I think this is probably going to be good for our directional light data specific stuff. So for that, I'm just going to call this dir light. Directional light is just too long, right? All right, so point lights. Point lights are another thing. So point lights, again, are in a structure where we have sort of, we have point light data, and then we have positional offset from whatever this may be attached to versus what's in the actual light data itself, which is the actual data that gets passed on to the shader. So again, I'm going to represent this. I'm going to represent this in a similar way that I did to the directional light. So we're just going to snag these properties out of here. And we'll create a new type doof, apparently. Type def. K-scene node type point light data. There we go. All right. So we have that. So that's color, position, constant, linear, and quadratic. That, however, we are going to have multiples of. And I don't know if I need to define a limit on the number of these that you can have in a scene. I think the only thing I need to define is like a limit of the number of them that will be drawn or that will be included in calculations in a single render pass, which right now is actually 4. So as far as the scene goes, it can have as many as it wants, so we can actually have a U16 allocated count. And then all of these are going to be arrays, right? And again, they are going to be indexed by an ID. And again, I don't know that this is actually going to work out any better. We're just going to try it, right? DOD it, exactly. So that's kind of what I'm thinking as far as that goes. So K-scene node point light data, point lights, right? Point lights, enough said about that. This is probably just needs directional lights, only one of these at a time. Okay, pretty much everything else is going to have multiples, right? So we have skybox and directional light are kind of special ones that we're only going to have one of. at a time. So that's going to cover these two guys. And then we actually have spawn points is another one. So spawn points is kind of an interesting one because that's going to have, let's see, type def struct, and then we'll do kscene node type spawn point data. Spawn point data. There we go. All right, so this is obviously going to have, it's going to require an Xform, right? Whereas not necessarily all other node types are going to require that, right? But this one definitely is going to require it. And so for this, we're going to want to put in, let's see, do we want to put... I'm actually debating on something right now because we actually have this, which is kind of our base node, you can kind of think of, right? So all nodes have these things. And I'm actually kind of leaning towards, like, do we just include this struct? But see, doing that would break the DoD, right? Or do we split this out somehow? Right, maybe we take transform ID out of this equation. Maybe transform ID is just included only on components that need it, or nodes that need it, and not included on nodes that definitely don't need it. I actually feel like that kind of makes a little bit more sense, right? Because otherwise we're going to have tons of these transform IDs floating around that don't actually translate to anything, right? DoD way to do this would be to have two lists, yes. So we do have two lists, right? So like this list right here is the list of sort of the base, right? And then if I were to want to access that from the concept of one of these, which I shouldn't actually ever have to do, come to think of it, then I would need to store the ID of the base here, right? And then that would be used to look up into the other table. But the only thing that I would ever actually need to get from that would be the transform. So I could just store the transform ID here and on the individual node types instead of doing it here. And I think that would also solve the problem. One with transform IDs and one without. Yeah, that's true too. But the reason I'm thinking of not doing that is because the only ones that don't use transforms are these two. And they are both single instance objects, right? You have one skybox and one directional light. So those aren't even really lists. Everything else actually has a transform, but I don't want to have to go into this list just to get a transform for this. Because I want to be able to iterate these very quickly, right? So I want data locality here. Whether or not I actually need it is really the question, though. Because if we think about it, when we are talking about a point light, the only thing that we need to do for a point light is we need to modify its position, right? And get its position and get its properties here to supply to a shader. So I'm actually kind of thinking this might be an example of something we might not DoD, you know? Are you casting shadows from point lights too, or only directional? So we're not at the moment, but we need to. That's on the to-do list, actually. Gunslinger girl. First time chat. I love the question, by the way, and yes, tons of times. I am making my own game engine, yes. Thank you for the follow, by the way. Yeah, I've been called that my entire life, yes. I'm used to it. In fact, whenever I'm spelling out my name, I always have to specify that it's a V, not a B. It's super annoying, actually, sometimes, but especially over the phone. System like yours that defines a scene on a text file, how would you package it to distribution? Do you include bytes in the exe, or do you encode it with custom formats? So, this is one of two formats that we have, right? So this is what we could think of as an intermediate format. So right now we're writing this by hand. When it comes time to, when we actually get ready to make the editor will be generating this. And so the runtime is capable of understanding this, but there will also be a binary version of this. That's already essentially split up into a configuration object that the scene is loaded using, so we don't have to parse this. And so when we actually go to load one of those scenes in a release build, we'll be looking at the binary version of it first, which we haven't actually defined, but that's basically just serializing binary data to disk, right? And as long as we avoid pointers and things like that, it'll be pretty easy to actually serialize. So this is sort of our intermediate / configuration file, or our source format, and then we'll have like a primary format that gets used after this, if that makes sense. Let's see. Learn OpenGL tutorial is useful to implement shadows from point lights, even if you're doing Vulkan. Same logic should apply. Do you plan to add CSM cascaded shadows? We already have CSM, actually. Yeah, we already have that. Yeah, so I mean the concept of shadow maps from point lights is pretty straightforward, actually, right? You just render a depth cube, 6 different directions. So you just aim the camera in each direction, take a snapshot of the scene that you can see, basically bounded by the radius of the light. So that way you're only capturing or rendering things that you need to for that, and then you use that depth map to actually cast your shadows. So it's not very difficult at all. It's just we haven't done it yet. Conceptually, it's pretty straightforward, actually. V and B also sound alike on the phone. Yes, they do. Yep. How many points would you realistically even have in a scene? Lots, right? So I'm thinking of densely populated towns or cities, right? That's going to have lots of lights all over the place. Or think about something like a cave full of crystals that glow, right? You're going to want to have lights around that. But we are also going to say for point lights, not all of them cast shadows, right? We're going to have a flag on it that says cast shadows. And then we actually have something already in our meshes that we can specify to say receive shadow and cast shadow, right? And so that will determine if it casts a shadow, it'll be included in the shadow map pass. And then if it receives a shadow, it will be included in the calculation for whether or not the shadow map is blocking the light from being received. Let's see. Ungoro crater. Yeah, I mean, kinda, right? I'm more thinking of like a cave, right? You walk into a dark cave, but there's like glowing crystals and stuff, or maybe there's a bunch of goblins in there and they've got torches along the wall or stuff like that. You'll need one for each one of those. And so eventually there will be limits on how many of those I'll render at once. So you won't want to like have a bunch of them tightly clustered together. You'll want to use them kind of sparingly. Otherwise you'll see them pop in and out based on proximity. I think right now we have a limit of 10 that we can actually render at once. And I ask from a newbie perspective, as I've only done 2D games so far. When you make a 3D game like Trine 2, for instance, do you load everything into memory in chunks or at once? Do you draw polygons every now and then or at once? Like a game like WoW Vanilla, does it handle drawing stuff on your screen? In 2D, I can apply frustum culling to thousands of quads, but when it comes to loaded 3D models, is it the same concept? So yeah, frustum culling is a big one, and occlusion volumes are another one. And so, yeah, those concepts very much do translate, right? It's just you're gonna use the frustum based off the camera that you're looking at or looking through, right? And then in terms of loading everything in chunks or at once, that depends on the game implementation itself. So we're gonna have zones where we go from one zone to the next. It's not going to be fully open world like WoW, so we're not going to be streaming in and out assets all the time. We're going to we stand up one zone, we load that in, we do whatever we're going to do, and then when we transition zones, we tear that one down and stand another one up. Do you use AABBs for frustum culling or OBBs? Neither right now. I use spheres because it's faster. So I basically just calculate extents, and then I use spheres, right? And I make sure that the sphere encapsulates the extents. It's cheap, but it works. Because I don't have to do, all it is at that point is just a distance check. I don't have to generate AABBs or any of that stuff, although I will eventually for like editor purposes, right? Yeah, it works. It's not great, right? It's not the most accurate thing, but it works. Okay. Let's see. Where were we? All right. So spawn point data. That's where we were. So, right, we were talking about transforms. So I do think I'm going to take... I think I'm going to take transform out. And put it where it's needed, right? So we're going to say that like all spawn points require transforms, right? All lights require transforms, right? Which means we could probably get rid of this position, right? And just use, extract that from the transform. So when we go to query light data, and we go to build the render data that we need for all of these things, right? The structures that are going to be used to pass this to the shader. At that point, we'll just grab the transform and say, hey, what's the position on this after you recalculate it? And I think that's probably going to be, that's probably what we should have done initially. View cone culling first, then view frustum culling easy. Yeah, that's true too. How does WoW do it? If it's open world, surely you cannot load the world into memory. Does that mean that they new delete things all the time in memory as you walk around? Yes, they do. Yep. I'm sure that they also have... I know for some things they'll use object pooling, right? So they'll use, for like the decorations on the ground, like the little rocks and stuff that you see on the terrain, they'll have a pool of those, say 100 of them, right? A max of 100 that they'll draw on the screen. And as you move through the scene, they will just move where those actually... They'll have all the spawn points sort of figured out for all of it, but they'll only render 100 of them at a time, or something like that, depending on your settings. And then in terms of actually like streaming in the assets and stuff like that, you're going to be constantly, loading those things in from disk, and shooting them up to the GPU to actually be rendered and pulling things down as you move. So generally speaking, the most common way to do it is you chunk it using like an octree or something like that, and you'll load in chunks at a time, and so you'll have the map will be split up into chunks, and you'll load everything in that chunk when you get close enough to it. And then once you get further enough away from it, usually once it's out of sight and then some a little bit, is when you'll actually unload it. So it'll load up before you actually get to it, and then it'll unload after you've actually moved away from it and after it's actually already out of the scene, right? Or out of what's the past the clipping plane, right? So yeah, they're constantly going to be streaming stuff in and out like that, because you're right, they can't load the whole thing to memory, right? And I'm pretty sure they're going to have some sort of system in there where like some things that appear throughout the scene, they'll just keep a pool of those in memory and just render them, right? And then like the specialty objects for like special buildings or something like that will only actually be loaded and or used when you actually get there. You telling me Blizzard uses actual new and delete? I wouldn't be surprised. I mean, yes, they probably pull it from some sort of. I'm sure they pull a lot of stuff from a pool or an arena or something like that. But I guarantee you they're creating objects all over the place. So, yeah. Access line bounding boxes checks could be easily done in clip space now if AABB faces are outside the normalized clip cube, then it's outside the view frustum. Yeah, you could do that. Although you kind of get that, I mean, you get discarded geometry anyways, but the whole object is to not load it, or not even have the draw call, right? You want to avoid the draw call. So generally you would call that using occlusion culling or a culling volume or something like that. Occlusion volume, whatever you want to call it, and or frustum culling. So there's several ways to cull stuff, and you would just basically, you want to limit that list of draw calls that's going to the CPU. You don't want to figure it out after it's already been sent to the CPU. Hope that makes sense. Like I think in their render code, they probably, you know, things like their scene graph and stuff, they probably pool memory like crazy. You know, they're probably super efficient at that level, but I can guarantee you their game code is not going to be that clean. Multiply the object bounding box coordinates by the view projection matrix, and you just test result coordinates again against the unit cube. Yeah. Oh, you're thinking of doing frustum calling on the compute shader. Well, yeah, okay, that's different then. That's something completely different. Yeah. All right. Okay, point light data. So I guess we use a transform for this. We use transform for that. The spawn points will also have. Actually, I guess that's it, right? Just a transform for now. We might actually have tags or something that we could use, or maybe something else to actually. There might be some other stuff. Like we could use like a radius, right? And this could be nodes can spawn randomly within this area, right? And so if that's a non-zero number, then maybe we could say, okay, well, if they spawn here at this particular spawn point, we've got a large radius on it, then you could use that to sort of make them spawn in slightly different locations within that. Okay. So spawn points, skeletal mesh is one. Hit sphere is easy. We can do that one real quick. Hit sphere is basically the same thing, but it has tags. But we already have tags, right? That's just a different thing, right? So we'll do hit sphere data and hit sphere data. Okay, and then the radius of the hit sphere. Yeah, I guess that makes sense. Okay, so KC, no, whoops. KC node spawn point data, spawn points. Hit spheres. Okay, static meshes are going to be next. So we'll do node type hit, oops, static mesh. There we go. And so the static mesh, if I recall correctly in the scene, I believe static meshes, let's see, mesh attachments, are just static mesh instances. Yes. So static mesh instances use the why did I suppose we could just take this and use it. Essentially, a static mesh instance is it uses the same underlying resource to actually render it, right? But you could have like a different material on it or a different instance of a material. And so the idea there is that you can use different materials with different states, or the same material but with different states across different static meshes. So for example, if you had an animated material and you wanted that animated material to go two different directions but on identical static mesh geometries using the same material, but maybe they just go opposite directions, you need two instances for that. So the static mesh instance is what we'd want to use there. So that is just going to be what do we want to do? I guess static mesh instances. Right, so there'd be one of those per static mesh, right? We'd also need a transform. And then we'd have an array of pointers to those, essentially, I'm thinking. And then down here, static meshes, right? Let's see. Volumes are going to be kind of something similar. So volumes actually have a few different things. I think we can actually use, we can actually use this as an example. So I'm actually just going to copy pasta this down here. So this is going to be volume data and volume. Okay, and then there was, I think we had a union for volumes. Scene volume, here we go. And I'm not going to, let's see, I'm not going to copy this structure directly because it's not exactly what we want, right? So we have the scene volume type, the shape type, and then a union for the shape config, right? So depending on the shape type, we're either going to use radius or we're going to use extent. So the shape type is either rectangle or sphere. And then we have these commands that are kept for the scenes themselves. And then hit sphere tag counts, which you could probably just use tags for this. We don't actually need like a specific hit sphere tag, I don't feel like. Or maybe we do. Because yeah, I guess that would be different than tags itself. Because like if we take a look at this volume here, this says that only when a player hits it does it actually activate, right? But we might also have other types of tags that we may use to select it that says, you know, maybe portals or something, right? And so if we wanted to select it by the portals tag, then we'd use that. But then if we want to determine what it actually interacts with in terms of hit spheres, that would be player. So I guess we kind of do need that. We could do something like that, right? Let's see. Looks like I missed some conversation here. Are you mastering facial hairstyle? I mean, sure. Let's see. Meshlet culling is a whole different game. Oh yeah, we're not doing meshlets. Not even getting into that can of worms. LaFoley, good to see you. Hope you're doing well. Pretty sure it would be best performed as the culling step, frustum, then occlusion, then meshlet. Yeah, I would agree with that. I would agree with that, Tammin, for sure. All right. All right, I'm going to move all of this over for right now, but indices into the scenes hit spheres array. Hit sphere indices. Oh, I think that was from... What did we use that for again? Iterate. Oh, right. I don't know that I love that implementation. Okay. We're going to redo how that works too. So I'm not going to take that bit. I'm not going to take the debug data either. I'm just going to take these. Okay. So we'll do this. And then we'll do an array of those unions, right? We'll do an array of the types, the shape types, and then an array of all these guys, right? Those are the strings of console commands to execute. And then hit sphere tag count and tags. I'm not 100% sure that I want to do this. I almost feel like we need a different view on this, but let's do that for now. Actually, let's put a to-do on this. To-do. Need a way to handle this better per volume hit sphere. Whoops. Set of tags. I mean, this will work, but it feels kind of hacky. All right, so volume data. There's volumes. Static mesh looks like water plane might be water plane and audio emitter are the last two. All right, so I guess let's do water plane next, right? Which is actually using the water plane structure, which again is not great. And we've got some weird stuff that's being stored here. Let's take all of this stuff and we'll leave the model matrix behind because we can get that from a transform, which we should be using anyways. So let's see, scene. Oops, not node type. That needs to have data on it. That's what it was. Okay, scene node type water plane data. All right, water plane vertex. So that's probably something we should probably standardize, right? Because why does this have its own? Why does this have its own vertex type? Right, it's just position. I mean, it's only just a few vertices, right? We could probably just use a vertex 3D and convert that, right? So I'm going to leave that in there because that's going to throw us if we do that now. Whoops. And then instance of the material. Okay, so we are going to have a set of these per water plane, right? So I'm wondering if we should just do it like this. And then offsets, and then material instances. And water planes are something that I can see us having more than one in the scene, although we need to really use them very sparingly because they're expensive to render. But I digress. All right, and then what's the last one? Audio emitter. Which this one we could probably use. We could probably use this, reuse this just as is. We don't need the name. And then we've got a handle into the audio system there. Okay. So Speaking of verbosity. Okay, scene. There we go. Sakelis Music, how are you doing? Good to see you. Is it actually more helpful to have line numbers be relative to the current line, or is it just something Vim users get used to? You actually have to explicitly set that. But what's really nice is like, if I wanted to go down, like let's say to the line where is streaming is, then all I have to do is hit 8J and I'm right to it. So it kind of allows me to, just jump that way. I don't use it enough, as much as I probably should, but it is useful for sure. Fast travel enabled, nice. Yeah, exactly. It's essentially what it is. Okay, so emitter data. Let me just plug this in real quick. Audio emitters. Okay. All right. So that is basically how we're going to handle all of those various types of nodes. I do need to go through here and put... Whoa. So we need that on audio or water plane, the audio. I think we got it on everything else. Okay, everything else has a transform. Perfect. Okay. So this is where we're probably going to wind up leaving it for tonight. Just because I do have work in the morning. So, with that said, let me see if I can find somebody to raid. And while I search, I just want to say thank you guys very much for tuning in, following along with me, and interacting and all that. I really appreciate it. If you guys haven't already, I would ask that you follow me on Twitch and or YouTube, because all of those follows really help me grow the channel and stuff, and they are greatly appreciated. Let's see. All right, I know who we're going to raid tonight. We are going to raid Odd Oculus. He is working in Unreal in C++. Looks like he's bug squashing tonight, so that might be interesting. And I see him in looks like the blueprint editor. So yeah, that should be pretty interesting to see what he's up to. And yeah, thank you guys for being here, hanging out with me, and I will catch you guys in the next stream. And to those on the YouTube side, have a good one. I'll see you guys later. See ya.